Welcome to Smart Learning MC Tech app. We are going to cover every topics of biology, chemistry and physics. Today we are going to cover chemistry from Smart Learning MC Tech. We are going to cover aldehydes, ketones and carboxylic acid as you can see in the screen. When we are talking about aldehydes, ketones and carboxylic acid, what are aldehydes? Aldehydes are organic compounds which have the functional group CHO. Aldehydes are organic compounds which have the functional group CHO. These carbonyl compounds consist of central carbonyl group carbon doubly bond to an oxygen and single bonded to the R group any alkyl group from a hydrogen bond. Now let's look preparation of aldehydes. Whenever we are looking about preparation of aldehydes, acid chloride are reduced to aldehydes with hydrogen in the presence of palladium catalyst spread on barium sulfate. Means acid chloride will get reduced to aldehydes with hydrogen in the presence of palladium catalyst spread on barium sulfate. Palladium catalyst is spread on barium sulfate. Acid chloride will get reduced on aldehydes with hydrogen in the presence of palladium catalyst spread on barium sulfate. This reaction is known as Rosenmund reaction, Rosenmund reduction, and is mostly used for the preparation of aromatic aldehydes. This reaction cannot be used for the preparation of ketones and formaldehyde. How acid chloride will get reduced aldehydes with hydrogen in the presence of palladium catalyst spread on barium sulfate. This reaction is also known as Rosenmund reduction and is mostly used for the preparation of aromatic aldehydes. This reaction cannot be used for the preparation of ketones and formaldehyde. Properties of aldehydes. Whenever we are going to talk about properties of aldehyde, the structure of aldehyde show a sp2 hybridized central carbon which is doubly connected to oxygen and has a single bond with hydrogen. Doubly connected with oxygen and a single bond of with hydrogen. sp2 will get hybridized central carbon which is doubly connected to oxygen, has a single bond and has a single bond with hydrogen. Hydrogen with single bond and oxygen with double bond. Small aldehydes are quite soluble in water. Small aldehydes are quite soluble in water. Formaldehyde and acetaldehyde are the great example of this. Formaldehyde and acetaldehyde are the greatest example. These two aldehydes are quite important industrial. What these two formaldehyde and acetaldehyde are very important in industrial purpose. Aldehydes generally exhibit a tendency to undergo oligomerization or polymerization. Aldehydes generally go oligomerization or polymerization. The carbonyl central atom center of the aldehyde has an electron withdrawing nature. Therefore, the aldehyde group can be considered somewhat polar. Why it is considered aldehyde as a polar, aldehyde group as a polar? It is because the carbonyl center of the aldehyde has an electron withdrawing nature. Electron has a withdrawing nature, therefore aldehyde group considered somewhat polar. These are the properties of aldehydes and properties of aldehydes. The structure of aldehyde show sp2 hybridized central atom which is doubly connected with two oxygen bond and has a single bond of hydrogen. Small aldehydes are quite soluble in water. Formaldehyde and acetaldehyde are great example of this. Two aldehydes are quite important industrial. Aldehydes generally exhibit a tendency to undergo oligomerization and polymerization. The carbon center withdrawing nature, therefore aldehyde group can be considered somewhat polar. Now we are going to look about nomenclature of aldehydes. Acyclic and aliphatic aldehyde are named after their longest carbon change along with the Al suffix minus Al suffix. For example, CS3, CS3, CS2, CHO is called butanol since it has four carbons in the chain. Like acyclic and aliphatic aldehydes are named after the longest carbon chain along with the minus Al suffix. For example, CS3, CS3, CH2 and CH and O, where butanol is called butanol since it has four carbons to its chain. When the aldehyde functional group is added to the ring and carbaldehyde suffix must be used. C6S11CHO is called cyclohexana carbaldehyde. In the case of natural compound, carboxylic acid minus oxo is used as a prefix to highlight the carbon which is a part of aldehyde group, a functional group. Example, CHOCH2N is called 3-oxopropenic acid, propanoic acid. Acyclic and aliphatic aldehydes named after the longest carbon chain. For example, Al suffix. For example, CS3, CS3, CS2 and CHO is called butanol since it has four carbon in the chain. When the aldehyde functional group is added to the ring, the carbaldehyde suffix must be used. For example, C6S11CHO is called cyclohexana carbaldehyde. Cyclohexana carbaldehyde. In the case of natural compounds or carboxylic acid, minus oxo is used as a prefix to highlight the carbon which is a part of aldehyde group. For example, CHO, CS2COH is called 3-oxopropanoic acid. Now we are going to learn about some common and IUPAC name, International Union Pure and Applied Chemistry. Names for aldehydes are tabulated below. Formula, common name and IUPAC name. Formula, first formula is HCHO. HCHO is known as formaldehyde methanol. Formaldehyde and IUPAC name is methanol. Next formula name is CS3CHO, which is known as acetaldehyde, and the IUPAC name is ethanol. CS3 is known as CHOI isobutyraldehyde. CH3CH3 CHO is known as isobutyraldehyde. 2 and its IUPAC name is 2-methylpropanol. Again the formula is CS3CH equals to CH minus CHO is known as crotonaldehyde, and its common IUPAC name is 2-buternal. Now we are going to learn about uses of aldehyde. Whenever we are going to talk about use of aldehyde, formaldehyde is used as a disinfectant as and as a preservative for biological specimen. Aldehyde is used for silvering mirrors. Formaldehyde is used for production of a variety of plastic and resins. Benzaldehyde is used as perfumery and in dye industry. For again revise, let's revise. Formaldehyde is used as a disinfectant, as a preservative for biological specimen. Aldehydes is used for silvering mirrors. Formaldehyde is used for the production of a variety of plastic and resins. Benzaldehyde is used in perfumery and in the dye industry. Benzaldehyde for formaldehyde is used in the variety of plastic and resins. Benzaldehyde means used in perfumery and in dye industry. Aldehyde is used for mirror silvering, and formaldehyde is used as a disinfectant and preservative for a natural biological specimen. Now let's learn what are ketones. What are ketones? When we talk about ketones are organic compounds which have the functional group called C double bond O, and the structure look like that, R minus E double O A minus R, like that. These carbonyl compounds have the carbon containing substituent on both sides of the carbon oxygen double bond. Carbon oxygen double bond, R minus carbon double bond O and minus R. This is the common hyphen. And carbon minus oxygen double bond. The carbonyl group keton group get sp2 hybridized. The structure of keton is a trigonal planar center and around the carbonyl plane. A keton structure look like a trigonal planar. The bond angle of the structure approximate at 120 degrees since the carbon oxygen bond makes the carbonyl group polar. Oxygen is electron withdrawing then carbon, so same it's again polar. Y aldehydes also are known as polar. Y withdrawing an electron from other carbon. Ketones tend to nucleophilic at oxygen atom and electrophilic at the carbon atom. Ketones are mass produced industrially for their uses as solvents and pharmaceuticals as precursor for polymers. Important ketones include methyl ethyl ketone, also called butanol, cyclohexanone, and acetone are the certain examples that are the important ketones. Again, let's revise. Methyl ethyl ketone, also called butanol, cyclohexanone, and acetone. Now let's look about preparation of ketones. How does the preparation get look? When we talk about preparation of ketones, acid chlorides on reaction with d-alkyl cadmium produce ketones. When acid chloride will get a reaction with d-alkyl cadmium, it will produce ketone. D-alkyl cadmium themselves are prepared from the Grignard reagents. This method is useful in a way that mixed ketones can be prepared very conveniently. These are the preparation how acid chlorides will get mixed with the d-alkyl cadmium to produce ketone. D-alkyl cadmium themselves prepared from Grignard region. This method is very useful for mixing ketone and prepared very conveniently. When we look about properties of ketones, ketones are polar in nature due to the presence of polar carbonyl group. Therefore, they have a higher boiling point and non-polar compound. They have non-polar compound and they have a higher boiling point. It cannot form any intermolecular hydrogen bond like alcohols because there is no hydrogen attached to an oxygen atom. Why